Hi student, this is lecture number 23 in the course Linear Algebra, and we are going to start with chapter 2, which is vector calculus. In the textbook it will be chapter 7, vectors, and we are going to need also chapter 9, vector calculus. So keep watching this video. In vector calculus, first we have to discuss the concepts of a vector. So we are going to learn about vector algebra in 2 and 3 spaces. Starting with the definition of a scalar and vector, a scalar is simply a real number or a quantity that has magnitude. For example about a scalar like length and temperature and blood pressure. But a vector is a quantity that has both magnitude and direction. For example, velocity and force. So a scalar has magnitude only, but in the vector it has magnitude and direction. A vector can be represented by an arrow. So this is a vector. It is represented by an arrow. Every vector has direction and magnitude, which means length, and have starting point A and terminal point B. A vector whose initial point is A, this is the initial point, and terminal point is B, this is the terminal point, is written as A, B, this direction. A is the initial point, B is the terminal point. Quality of vectors. 2 vectors A and B are equal, written A equal to B, if they have the same length and same direction. So vector A equal to B if they have the same direction and same length. Like here, those are equal vectors, but in this example, those 2 vectors having same length but different direction, not equal. This is not equal, they have the same direction but different length. Here, vectors having different length and different direction. Next we have a vector in 2 dimension and a vector in a 3 dimension or 3 space. So a vector A in R square or 2 dimension or 2 space is any ordered pair of real numbers, like this. This is a vector, it is ordered pair of real numbers. For example, the vector 1, 2, it is a 2 dimension vector. A1, A2 are called components of the vector. 2 dimension mean the x-axis and the y-axis. This is the 2 dimension. 3 dimension mean x-axis, y-axis and z-axis. This is the 3 dimension, or we call it Cartesian coordinate system or R cube. A vector A in R cube is any ordered triple of real numbers. So the vector in 3 dimension will look like A1, A2, A3. It is ordered triple where A1, A2, A3 are called components of the vector. A position vector R of a point A is the vector whose initial point is the origin 0, 0, 0 and the terminal point is A. So this vector is called position vector R of the point A and is denoted by R. Example, find the position vector R of the point A, which is 2 minus 2, 5, which is a 3 dimension. This is the 3 dimension space. This is the y-axis and this is x-axis and this is the z-axis. we have origin here, which is 0, 0, 0. Also, we have a minus y from this side, and this is positive x, negative x is from this side. This is positive z, negative z is from this side. So this will be minus y, and this will be minus x, and this is minus z. So let us find this point, which is 2 minus 2, 5. 2 is from x-axis, this is from y-axis, and this is from z-axis. 2 from positive x, it will be, this is 1, this is 2 here. Then minus 2 from y, this is positive y, minus 2 from y will be here. We have to make those meet together. They will meet here. So this is 2 minus 2. Then we have 5 from z. So height will be 5 from z. Suppose this is 1, 2, 3, 4, 5. So it will be here. So this point here is 2 minus 2, 5. The question is find a position vector r. So a position vector is a vector whose initial point is the origin and the terminal point is this given point. So the vector r will start from origin point to this point. This vector is the position vector r. Addition, scalar multiplication, equality of vectors. So we have two vectors A and B. Both of them are 3-dimensional. Number 1, addition. So how to add vector A and B? To add those two vectors, we need to add the components. So we're going to add A1 with B1, comma, then we add A2 with B2, and we add A3 with B3. This is the addition. Number 2, scalar multiplication. How to multiply a scalar, which is a real number, by a vector A. Answer will be, we need to multiply each component of vector A by k. So it will be KA1, KA2, and KA3. K is a scalar, which is a real number. Equality, A equal to B, so vector A is equal to vector B if and only if A1 is equal to B1 and A2 is equal to B2 and A3 is equal to B3. Number 4, negative, which is minus vector A. It is multiplying each component by minus 1. 5, 0 vector is a vector whose all components are 0. So for the vector we use bold capital letter O. For component we use 0. 6, we have magnitude or length, or it is called also norm. So the length of vector A is equal square root A1 square plus A2 square plus A3 square. Also, if we have a vector which is A, like this is the direction of A and this is the direction of B. So the vector which is start from here and this is the terminal point, it is A plus B. Example, the vector A has initial point P and terminal point Q. So it is like this vector with initial point is P, terminal point is Q, and we need to find the vector A, this vector. We need to find the first component A1 and then A2 and A3. A1 will be terminal point minus initial point. That means 6 minus 4, which is 2. This is the A1, then minus 1 minus 0. This is A2, which is equal to minus 1. And then third component, which is 2 minus 2 equal to 0. So our vector is equal to 2 minus 1, 0. Now we want to find the length of the vector. The rule of the length is, and we need to substitute A1 is 2, A2 is minus 1 and 0. We get the length of vector A, square root of 5. So to find any vector, we need the initial point and the terminal point to find our vector. Properties of a vector. Property number 1, A plus B equal B plus A. And this is called commutative law. Number 2, A plus B plus C equal A plus B plus C. This is called associative law. Number 3, A plus 0 vector is equal to 0 vector plus A, and the answer is vector A. Number 4, A plus minus A will give us 0 vector. Now 5, K is a scalar, multiplied by this we will get KA plus KB. K is a real number. Both C and K are scalar, so we need to multiply the vector with both of them. Answer will be CA plus KA. Number 7, both C and K are scalars, so this will be same like if we multiply the two scalars together, then we multiply them by vector A. 8, 1 times vector A, it will give us vector A. 9, 0 number multiplied by a vector A, it will give us 0 vector. We have now unit vectors. So a vector that has length equal to 1 is called a unit vector. So if your vector, the length of your vector is 1, this is called unit vector. If it is vector A or B, whatever. A unit vector U in the direction of a vector A is given by the following. So if we want to find a vector which is same direction as vector A, but the length is 1, this is how to find it. Suppose this is vector A, and we want to find another vector U having length 1 and the direction of this vector same direction like A, we use this rule. If we want it to be opposite direction to A, the U, so we have to multiply it with minus. Example, find a unit vector in the same direction of A. So the rule is U equal vector A divided by magnitude of A. First we find the length of vector A, which is square root of 17. Then we put it here, and vector A we put it here. We get the following, and it's equal to this. To check your answer is right, if you find the magnitude of vector U, you will get 1 because it is unit vector which has length 1. An example about unit vector is ijk, where I is equal 1, 0, 0, j is 0, 1, 0, and the k is 0, 0, 1. Also, if you find the length of vector I, you will get 1. This is the length of vector j, you will get 1, and the length of vector k equal to 1, so it is unit vectors. Exercise 7.1 from the textbook. Homework for you 4, 2, 10, and 14. I will solve 1. Also, homework is 23. I will solve 25. Also, this exercise is homework. I will solve 49. And this is the solution of exercise number 1 and exercise number 25 and 49.